Okay, admit all. Now, okay, so if I just move this down a bit and move this up a bit. Just give me a sec, I'm trying to sort out all this crap. Right, okay, so exponential graphs, girls, right, okay, so what an exponential graph is, right, okay, is a function of the form where the letter is in the power. So a function where x is in, oh God, the power, sorry, I'd all this written out and I rubbed it all out, rubbing my hands on it, right, where x is in the power, so that reads, is in the power. The power is called an exponential function. For example, f of x equals 2 to the power of x. F of x is equal to 3 to the power of x. F of x equals 2 multiplied by 2 to the power of x. So the letter is in the power. This is a multiply sign, girls. I didn't put an actual multiply sign because it looked like an x then. So I just put a dot for the multiply sign. Okay.
Miss, you know the sign where it's f of x is equal to 2 and then 2 of x, what's the, is that the multiply sign?
Yeah, that's a multiply sign. Okay, yeah. I didn't put a multiply sign because it looked like an x and that'd be really confusing. So it's a dot, means multiply. So that's like 2 multiplied by 2 to the power of x. Something like that, okay? And remember, write any number to the power of 0, that's 2. Any number to the power of 0 is 1. For example, 2 to the power of 0 is 1, 3 to the power of 0 is 1, x to the power of 0 is 1, 100 to the power of 0 is 1. Right, okay, and if you check it out in a calculator, if you can't remember it, the calculator will do it for you. Okay, so we're going to go straight to an example now where we graph one, and then we're going to look at the graph and we're going to make a few observations about it. Okay, so can I move on? Is that down?
Yeah, no.
No, it's grand, I'll wait.
Yeah.
Right? We all good? Right, okay. So here's an example of one you have to graph. Graph f of x equals 2 to the power of x in the domain, right, between -2 and 3. So there's your start, there's your end. Okay, so I'll do it out by hand, right, okay, and that's 2 to the power -2. This is 2 to the power -1. 2 to the power -2 is a quarter. On the calculator, it's sorted. So it's -2, a quarter. 2 to the power -1 is a half. So that's -1, a half. This is 2 to the power of 0, anything to the power of 0 is 1. So I put in a 0, got out a 1, right? 2 to the power of 1 is 2, so that means x is 1 and y is 2. 2 to the power of 2 is 4, so I put in a 2 and got out a 4. And 2 to the power of 3 is 8, so I put in a 2, 3 even, and got out an 8. Okay, right, so that's how we do it by hand on the calculator, same as normal. Okay, you press mode and number 3 for table. F of x equals 2 to the power of x. So 2 to the power of, is this one here, see the x with the kind of blank, right, with the x with the kind of square, coloured in square up in the power. Press that and then you have to put your x in there. So alpha and the close bracket will get in your x. So, right, okay, don't mind that screen because you won't get that. The start is -2. So start with -2. End is 3 and it's always step 1, and then your table comes up. So they just have them in decimal form. So instead of a quarter, they have -2, 0.25, so they give it in decimal form. And here, instead of a half, they have 0.5. But everything else then, all those points. So you can use your calculator like before. Okay? So,
Miss Emerald,
yes?
Grace Palmer's Wi-Fi is down, so she's not in the meeting.
Right, okay, I'll be recording the class anyway, I am recording the class, so I'll stick it up. Okay, right. We're good to draw? Okay, so then to draw, so I have -2, a quarter. So across to -2, up a quarter is about here, right? -1, a half is here. 0, 1 is here. Then I have 1, 2, 2, 4, and 3, 8. Okay, so your graph looks like this.
Miss Enright,
Yes.
do you know the way if it's like up a quarter, like obviously people are going to have like different kind of...
Yeah, estimate, yeah.
Yeah, so it doesn't really...
Yeah, oh, it doesn't have to be exact, no, you know, you're not a computer, like, so in or around the quarter is up, right, and if it's a bit past it or a bit short of it, not a big deal, okay, is that right? So I just guessed it there, right, okay, so there's your graph, okay, so I'll leave you write that down and then we'll make a few observations about this graph.
Miss,
Yes.
do you know for like the -2 and a quarter bit, how many points could you lose on your graph for not being like extremely accurate?
Oh, none, no. As long as it's thereabouts, right? As long as it's not up at 1 or, you know, completely in the wrong position. If it's anywhere between 0 and 1, they'll give you the max, okay? Because they know you're not a computer, so, yeah.
Okay, thanks.
Yeah, so don't worry about it, in and around a quarter, okay? Right. Okay, I'll ask you in a minute, are you finished? I presume you're still doing it. Ready? Just say no if you're not. Ready?
Yeah.
No no's. Okay, everyone's ready. Right, this is the COVID-19 graph, girls. This is the exponential. It gets really big, really fast, right? So, you know, if you think COVID-19, it started off at 1 person, and then it was 2 people, then it was 4 people, then it was 8 people, right? Then it was 16 people, do you know what I mean? So an exponential curve gets really big, really fast. That's the first observation, right? So it gets really big, really fast. Obviously, COVID didn't have any of the negative side, right? Okay, because you can't have negative people, right? Okay, but gets really big, really fast, right? That's the first thing, right? Okay, so observations about the graph, I'll leave you write them down and then we'll come back. So exponential functions get very big, very fast, and I just put COVID-19 in there because, you know, they're talking about flattening the curve and whatever, it's an exponential curve, so it's getting really big really fast, right? Okay, so I'll talk about this one in a minute. I'll talk about the whole lot of them actually in a minute. The higher the value of A in the function, yeah, the curve will get closer and closer to the x. Right, okay, I'll talk about them all in a minute. I'll leave you jot them down first, because I want to look at the graph when we're talking about them. Right, you ready? Say no.
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 Okay, yeah, lots of no's. I'll wait.
Missed your last one.
Yeah, the higher the value of A in the function f of x equals a to the power of x, the nearer it is to the y-axis. Did I read the bit? Sorry, bad writing, sorry. Right, are you ready? Say no.
Yeah.
Yeah, so okay, right, so I'm just going to go back to this graph, right, okay, to tell you, to talk about each one of those. So the first thing is it gets really big really fast, right, I've spoken to that, right. Basically they will all cross here at 1, so we'll see if f of x equals 3 to the power of x, it'll cross at 1. I'm going to draw that one in a minute, and I'm going to draw in f of x is equal to 10 to the power of x. I'll draw those in a minute, right, okay, right, but they all cross at 1, so because 2 to the power, or anything to the power of 0 is 1, so 3 to the power of 0 is 1, 10 to the power of 0 is 1, 100 to the power of 0 is 1, so all these graphs, all these exponential graphs cross at 1, right. This way, guys, they're getting close. The third point you wrote down was it's getting closer and closer to the x-axis. Like that was a quarter. The next one back here would be an eighth. Then it'd be a 16th. Then it'd be 1 over 32. So it gets nearer and nearer to the x-axis, but it never gets to the x-axis. So it's impossible to even draw it, get nearer and nearer, because your pen would be too thick, right? But it gets closer and closer to the x-axis the further back you go, but it never actually touches the x-axis. It'll never touch the x-axis, right? And the higher the value of A, right, this is A, this number here. So this is 2 to the power of x. 3 to the power of x is higher. So if I was to draw in 3 to the power of x, girls, it would be something like that. So that would be 3 to the power of x. Right, okay, it's kind of closer to the y-axis, right, and it's closer to the x-axis. 10 to the power of x would even be underneath again, so 10 to the power of x would be here. So the bigger this number, so the 4 point means the bigger this number, the nearer it is to the y-axis. Okay, so 100 to the power of x will be in here somewhere. 200 to the power of x would be closer again. Do you know what I mean? The bigger that number, the closer it is to the y-axis. This is the y-axis, so it's in here. So the bigger the number, the closer it is. Okay? Right? And when you that one down, I'm going to go to the book and do an example of some of the questions, because the theory is kind of harder than the questions, as in when you get to the questions, they're okay, like, okay, right, and we'll be able to pick up any of the other facts I need to know. So when you have this down, you might open page 183, right, so you might open page 183, okay? Right, can I take this away and put it 183? Okay, so page 183, I'm going to do the first couple of questions with you, and then I'm going to leave you off to do a few, right, okay? So, here's a graph of 2 to the power of x, we just drew that there a minute ago, right, okay? And then they said, hang on now, I'll just root out my ruler. Right, okay, so the same questions as before. F of 0, right, means x is 0. So you go to 0 on the x-axis, draw a line up to hit the graph, and read out your answer. So what's f of 0? F of 0 is 1, isn't it? Right, f of 1, that means x is 1, so I go to 1 on the x-axis, draw a line up, hit the graph, draw a line across, read out the answer, so the answer is 2, isn't it? Right, f of 1.5 is halfway between 1 and 2, so go up, go across, right, okay, and I'm looking at 3, right, but it might be very accurate there, okay, so the answer is 3, right? F of 3 is not shown on the graph, so they didn't show, when x was 3, they didn't put the point there. For what value of, sorry, f of 3 is not shown on the graph. What is f of 3? It's 2 to the power of 3, which is 8, okay? And for what value of x is f of x equal to 5? So remember, they're telling me y. So if they're telling me y, they're asking me for x. So I go to the y-axis, I go to 5 on the y-axis, draw a line across, hit the graph, draw a line down, read off the answer. So I'm looking at 2.2, 2.1, 2.3, I don't know, in or bound. Okay, is that right? Copy and complete the following table and draw the graph. So into your calculator you put 3 to the power of x, you start with -2 and you finish with 3. So 3 to the power -2 into a calculator is 1 over 9. 3 to the power of 0 is 1, 3 to the power of 1 is 3, 3 to the power of 2 is 9, 3 to the power of 3 is 27, and you graph those, okay? And then use your graph to write down f of that, so that's x, so you go to the x-axis, you go to 1.5 on the x-axis, draw a line up, draw a line across, right? And here they're telling me y, okay? I'm kind of flying through this now, but I think we probably need to draw out a few. So I'm going to leave you off now, and you're going to do page 183 to 184, and you're going to have a go at 3, 4, and 5. 3, 4, and 5. Okay? So, and we'll have a Zoom class tomorrow again, okay? So 3, 4, and 5, page 183 to 184. So you can head off now, right, when you've that down. Okay? And we'll class tomorrow, okay? Bye. Bye now.
Thank you.